All right, this is Mr. Lundy here again with another lesson on naming. Today we are doing the Level 2, Episode 4, Luke Skywalker Transition Ionic Naming. So if you're following along in the guided notes, go ahead and flip to that section. If you watched the last video, we focused on binary ionic compounds, which was a metal with a set charge combined with a nonmetal. The difference is today, with transition ionic naming, we will be dealing with a metal that does not have a set charge. It will have more than one charge. We'll call this an either-or metal, and we'll combine this with a nonmetal. And these either-or metals are found in the middle of the periodic table, but they are not our bing, 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 a 1, 2, 3, silver, zinc, or aluminum. Okay, they're in the middle, but they're neither of those three. So, start off, we'll just put some examples down. So, in our example section, we have CuI, we have MgO, we have Fe2O3, and CuI2. So, kind of like our binary compounds, we will start by writing out the name of our metal. So that is copper. Cu is copper. And since we are dealing with a transition metal, we will always put a pair of parentheses right there in the middle. And then we're going to write our nonmetal, and we'll do the same thing as we did with our binary compounds. We will change its suffix to "ide." So we have iodine, and we'll change its suffix to "ide," making it iodide. But we got to figure out what to put in this parentheses. So to do that, we will look at the charge of our nonmetal, and we know that when we're creating a compound, we want the overall charge of that to be 0. So if we look at our charge of I is a halogen. It has a -1 charge. So if we want to find out what the charge of our metal is, we can set this equal to 0. We know we're going to have to add another charge here. And if we add 1 over to this side, we're looking for our X theoretically here. That gives us a +1 here. And if you add a +1 to a -1, you get 0. Therefore, you can put a Roman numeral 1 in your parentheses there, because our charge on copper is a +1. So the next example, we have MgO. If you guys look on your periodic table, you're going to remember that Mg is actually a group 2 metal. So it has a set charge, of a +2. O has a set charge of -2. And so this actually isn't a transition compound. So this is just a regular binary. I just threw it in so that you could see the difference between the two. But we would just name this like normal. Magnesium oxide. Alright, next we have Fe2O3. We do know Fe is in the middle of our periodic table. So we can start out by looking at the charge of our oxygen. Our oxygen has a -2 charge. And by looking at the number below oxygen, we know that we have 3 of these. So we're going to need to add that to something to get us equal to 0. Well, we know that looking at our Fe, we have 2 Fe ions. So we're solving for that X there. We know that this equals -6. So we know that whatever we put over here is going to have to equal +6. And if we divide 6 by 2, we get 3. We know our X equals 3. So our Fe has a +3 charge. So we're going to write that out. We have iron, parentheses, because it's a transition. And our charge is 3. So you can write a Roman numeral 3. And then we have oxide. Okay, so for our last example here, we're going to use a different method. And in the last section we talked about the crisscross method. But in this section, we're kind of going to be doing it backwards. So we're going to use the cross-cris method. So if you have nothing beneath this copper right here, you know there's actually a silent 1 here. And you've got a 2 on your iodine. So in our cross-cris method, we're basically going to be bringing everything backwards across. If you remember from the other one, we had our charges up top, and we brought them diagonal down. This one, we have our numbers of each ion on the bottom, and we're going to bring it diagonal to the top to get our charges. So when we bring the 1 across, we know that makes a -1 because iodine is a non-metal, it has a negative charge. And then our 2, we're going to bring that up above our metal. That's going to give us a +2 charge here. So we check our work. We can do that by looking at the number of iodines. We multiply, because we know we have 2 iodines here. 2 times -1 is -2 plus a +2. That gives us 0. Our cross-cris method worked. So we know that we have copper 2 oxide. And if you look, you notice that copper can have 2 different charges, because up top, right here when we only have 1 iodine, our copper has a +1 charge. But down at the bottom, when we have 2 iodines bonded to our copper, we suddenly have a +2 charge on our copper. So that's a good example of how transition metals can have more than one charge. So now we are going to kind of go backwards, and we are going to start with our name, and we are going to write out the formula. So to start out, we have a few examples. Nickel to oxide. We also have iron 3 sulfide. And we also have chromium 2 phosphide. So in our first one, we can start out like we did with our binaries. We're going to start by writing out the symbols. So for nickel oxide, we know we're going to have an Ni and an O. We know that O has a -2 charge. And we know that our Ni, because of the Roman numeral here, has a +2 charge. So then we can do our crisscross, can bring our numbers down. We know that we all have a 2 here and a 2 here, and we know that that reduces so that we can basically just have 1s under each of those numbers. So then our formula is just NiO. For our second one, iron has a symbol of Fe. Sulfide is sulfur with the symbol of S. And we know that our sulfur has a -2 charge. Our Fe has a +3 charge. And we do our crisscross method again, bring down our numbers, and that gives us Fe2S3. And for our last one, we have chromium, Cr, and phosphide, P. Our phosphide has a charge of -3, and our chromium has a charge of +2. So if we do our crisscross, we bring our numbers down, and we end up with Cr3P2. And that is basically an overview of naming with transition metals. Remember, these are either or metals because they can have more than one charge, and they're found in the middle of the periodic table. So if you're looking at your periodic table when you're doing your naming, just double check and see where the metal is that you're using for naming, and you should always be able to find the right answer.